Okay, so today we're going to be talking about graphing sine functions and cosine functions. Okay. The first thing we want to think about is that unit circle that we've discussed in the past. So let's go ahead and take a look at that first. So if I start looking at these points right here, please keep in mind that all of those points are representing cosine comma sine. So if I'm looking just at the sine function, we're only going to be looking at these y values or the sine values. You'll notice when we're looking at 0 radians, the sine value is 0. When we're looking at pi over 2 radians, the sine value is 1. When we're looking at pi radians, the sine value is 0. When we're looking at 3 pi over 2 radians, the sine value is -1. So I'm going to fill in my first chart using those values. In this chart, when the radians were 0, the sine value was also 0. When the radian was pi over 2, the sine value was 1. When we're talking about pi radians, the sine value was 0. For 3 pi over 2 radians, the sine value was -1. And for 2 pi radians, the sine value again was 0. Now if I plot this, I would have 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, -1, and 2 pi, 0. And this, once I draw my curve, is what the sine function would look like. Now this right here is from the interval 0 to 2 pi. Okay, but notice it wants us to graph it on the interval -2 pi to 2 pi. Well, if you put this into your calculator, this is what you'll see. So you can see that we've already plotted this part of the graph. Okay, but we have to go ahead and plot the -2 pi to 0 part. From here to here is known as the typical period of a sine function. The typical period for a sine function is from 0 to 2 pi. In order to plot the part over on this side of the axis, all we're going to do essentially is copy this shape and now paste it over here. Okay? We just repeat this one period over on the other side of the axis in order to plot from -2 pi to 2 pi. So I'm going to go ahead and essentially I'll move backwards. So if I start right here, that's like starting over here. Okay. So my next point would be at -1. So I'm going to make a point at -1. Then I'd have a point at 0. So I'm going to make a point at 0. Then I have a point at where my y value is 1. So here I'm going to make a point where my y value is 1. Okay. And finally it goes back to when my y value is 0. So I'm going to put a point where this y value is 0. Okay. You can see essentially we're just copying that same shape over on the left side. Okay. In order to get your graphing calculator to show this image, okay, you're going to want to make sure that you set your mode to radians and then push zoom trig. Okay. The next one is the cosine function. So again, let's go ahead and go back to where we were looking at our unit circle before. And now rather than looking at the sine values, let's look at those cosine values. So again, keep in mind that all these points are written as cosine comma sine. So if I'm looking at my 0 radians, my pi over 2 radians, my pi radians, and my 3 pi over 2 radians, let's look at the values for cosine. Here we have at 0 radians, it's 1. pi over 2 radians, we have 0. At pi radians, we have -1. And at 3 pi over 2, we have 0. And then if we go all the way a full revolution, 2 pi, again, we'll have cosine is 1. So when we're filling out this chart, at 0, cosine is 1. At pi over 2, cosine is 0. At pi, cosine is -1. At 3 pi over 2, cosine is 0. And at 2 pi, cosine is 1. So we plot these. We have 0, 1. Pi over 2, 0. Pi, -1. 3 pi over 2, 0. And 2 pi, 1. Okay. Again, this is the typical shape for a cosine function. The period, again, is 0 to 2 pi. Okay. So if I want to replicate this same shape across the interval -2 pi to 2 pi, okay, I like to work backwards. You can see at 2 pi we have cosine is 1, and here we have that cosine is 1. So to replicate this, I'm going to go ahead and just work backwards. The next point, the y value is 0. So here at the -pi over 2, I'm going to put 0. At pi, it was -1. So here on the left side, my next point is going to be at y value is going to be at -1. Then this increased, we're at pi over 2. The y value was 0. So over here, I'm going to put 0. And then again, we see a y value of 1 there. So for over here, I'll put a y value of 1. And you'll see that we've basically copy pasted this shape over here. Okay, it's the same shape, it's just that since we're dealing with a new period, okay, that same shape's going to repeat. Okay. That's all a period is. It's just the horizontal distance before the values begin to repeat. Okay. So now we're going to compare. It says to graph these on the graphing calculator, and we want to describe the changes from the parent functions above. So the first one we're going to look at, this is if we were to graph y equals 2 sine x on the calculator. For a typical sine function at 0 radians, it's 0. Okay, at pi over 2 radians, we have that the sine function is 1. At pi radians, sine is 0. At 3 pi over 2 radians, we have -1. And at 2 pi radians, we have 0. So this is what the typical sine function looks like. Okay, and that same shape would be over here as well. Okay. So how is that different? Well, we can see that now rather than going up 1 here, it's going up 2. And same with the decrease here. Instead of going down 1, we can see that now that curve is going down 2. So what I want you to notice here is that when we have that value in front of our trig function, it's just telling you what to multiply the y values by. It's how far up or down the function goes from the midline. So in this case, the midline is going to be right through here, right? So now rather than going up 1 from the midline, we're going up 2. Here, rather than going down 1 from the midline, we're going down 2. Okay? So whenever you see a number out in front of a function, I want you to multiply the y values by the number. So multiply output values by 2 in this case. Okay? So before, when we had 0, 0, okay, if we multiply that by 2, that output value by 2, we still have 0. But now, rather than at pi over 2, rather than having an output value of 1, I now see that I have an output value of 2. Okay. If we look at pi, okay, so this is 0, this is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi. Now when we look at pi, we see that we still have an output value of 0. 3 pi over 2, now rather than having -1 as our output value, we have -2 as our output value. And at 2 pi, we still have 0. Okay. So let's take a look at our cosine function now. This next graph right here represents cosine x plus 2. Okay. Remember what our typical cosine function looked like? At 0 radians, cosine was 1. At pi over 2 radians, cosine was 0. At pi radians, cosine was -1. At 3 pi over 2 radians, cosine was 0. And at 2 pi radians, cosine was 1. This is 2 pi radians. Okay. So my typical cosine function over one period looked like this. Okay. And if we copied it, okay, we copied that appearance of the cosine function to a separate period, it would look like this. Okay, so that was our parent cosine function. How does cosine x plus 2 affect this original cosine graph? Well, we can see that the whole graph has just been shifted up 2 units. Okay. So whenever I see that value either added or subtracted onto the end, that is going to tell you your vertical shift. So here I want you to think up 2 or add 2 to output values. Okay, so where originally I had that for the parent function when we were dealing with 0 radians, we had an output value of 1. Now take a look at what our output value would be. It would be not 1, but 3. We add 2. Where my original value for the cosine function at pi over 2 would be 0, now I add 2. So instead of having 0 there, if I add 2, I will be at 2. Okay. If I look at pi over 2, now you can see that I'm at 2. Okay. For pi, or before for my parent cosine function, at pi I was at -1. Now I would add 2, and I would be at 1. So here I should see a point pi 1. There's my point pi 1. Okay. At 3 pi over 2, before where I saw that cosine was 0, again I should have an output value of 2. And last but not least, when my output value for 2 pi for the parent function was 1, now my output value, add 2, I'll be at 3. Okay, so these are my new cosine x plus 2 outputs. Okay, if you want to see this in your calculator, make sure you do zoom trig and put your table set so that you start at 0 and your delta is pi over 2, or your intervals are pi over 2. Okay, so here's a summary. And the first one says to multiply former y values by a. This is known as the amplitude, or in other words, it's how far up or down the function goes from the midline. So our example of that was when we had y equals 2 sine x. 2 is your amplitude, and that's how far up and down the function is going to go from the midline. Okay, that's what you want to multiply the former y values by. Okay. The second thing we talked about is if you have a plus or minus d, in other words, we talked about cosine x plus 2. Here, this plus 2 indicated your vertical shift, okay, and it'll also affect your midline. Your midline will be at y equals d, or in this case, it would be at y equals 2 for this problem. Okay. No matter what you're multiplying the y values by or adding or subtracting from the y values, to graph you're always going to want to use your key points and shift to help you replot your sine and cosine. So we're going to be looking at the parent function and then either multiplying y values by the amplitude or adding or subtracting something for the vertical shift. Okay, so here's my first example. It says graph 3 cosine x. Okay, so because this is out in front, I know this is my amplitude. So I'm going to multiply y values by 3. Okay. Remember my original cosine values? When we were dealing with 0 radians, cosine was 1. At pi over 2 radians, cosine 0. Pi, cosine's negative 1. 3 pi over 2, 0. And 2 pi, 1. Okay. So I'm going to take those original values and I'm going to multiply them by 3. So 1 times 3 is 3. 0 times 3 is 0. Negative 1 times 3 is negative 3. 0 times 3 is 0. 1 times 3 is 3. So my new points that I'm going to plot are 0, 3. Pi over 2, 0. Pi, negative 3. 3 pi over 2, 0. And 2 pi, 3. Those are the points I'm going to be plotting. 0, 3. Pi over 2, 0. Pi, negative 3. 3 pi over 2, 0. And 2 pi, 3. And we can see that has the typical cosine shape that we're looking for. It does want us to plot it over negative pi to 2 pi. So currently it's only plotted over 0 to 2 pi. So we're going to have to fill the rest in. Again, this is the horizontal, it's only depicting the one period. Okay, so now these values are going to start repeating. So here, if this is at 3, this will be at 3. If this next one is at 0, then this next one will be at 0. If this one is at negative 3, then the next one over here will be at negative 3. If this one right here is at 0, then the next one over here will be at 0. And finally, if this one is at positive 3, then the next one over here will be at positive 3. So you can see it's almost as if we copy pasted that same photo over to the left-hand side of the graph. Okay. All right, the next one says graph negative sine x plus 4. So let's just fill in our radians first for the x values. 0 radians, pi over 2 radians, pi radians, 3 pi over 2 radians, and 2 pi. Same radians we worked with before. The typical sine functions at 0 radians, the sine is 0. At pi over 2 radians, sine is 1. At pi radians, sine is 0. At 3 pi over 2 radians, sine is negative 1. And at 2 pi radians, sine is 0. Okay. Now, let's first look at the amplitude. So the amplitude is -1. So I'm going to multiply y values by -1. So here, I'm going to multiply 0 by -1. That's still 0. 1 times -1 is -1. 0 times -1 is 0. -1 times -1 is +1. 0 times -1 is 0. Okay? Then I have to look here, +4. This is the vertical shift. We're moving up 4. So we're adding 4. Okay? So now I'm going to go ahead and add 4. Add 4 to 0. Be at 4. Add 4 to -1. I'll be at 3. Add 4 here. I'm at 4. Add 4 to 1. I'm at 5. And add 4 here, and I'm at 4. So now what points am I dealing with? X value 0 outputs 4. X value is pi over 2 outputs 3. X value is pi outputs 4. X value is 3 pi over 2 outputs 5. X value 2 pi, output value 4. Okay. So now I go ahead and plot those. Alright, so I'm going to plot 0, 4, pi over 2, 3, pi 4, 3 pi over 2, 5, and 2 pi 4. And this is what your curve's going to look like. Okay. Again, I'm going to fix this really fast. And then I'm going to copy paste this curve over here. Okay. And that is what that function is going to look like. Okay. Last but not least, we'll take a look at this function. Okay, and fill in my radians. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay. My sine values are typically 0, 1, 0, -1, and 0. Now for the 2, okay, I'm going to multiply my y values by 2. 0, 1 times 2 is 2, 0 times 2 is 0, -1 times 2 is -2, 0 times 2 is 0. And then now here I'm going to subtract 3. So I have -3, -1, -3, -5, and -3. So here's my points. 0, -3, pi over 2, -1, pi, -3, 3 pi over 2, -5, and 2 pi, -3. Okay, 0, -3, pi over 2, -1, pi, -3, 3 pi over 2, -5, 2 pi, -3. And this is what my graph looks like. Okay, again, I'm going to copy it over here. So if I have this point, that's this point. This next point is going to be this next point. This point is going to be this point. Okay. This next point will be this next point. And finally, this last point will be this last point. Okay, and you can see it looks the exact same. One period of this, remember, a period is the horizontal distance before values begin to repeat. So as we can see, this was our one period. And then these were, the values started repeating. Okay, so one period was 2 pi long. Okay. What was our amplitude? Well, remember our amplitude's out front. Okay, and that was 2. Okay, the amplitude is all the amplitude is how far up or down the function goes from the midline. So what is the midline here? Well, the midline was y equals d. So in this case, this is our d value. So our midline was at y equals -3. Okay, so if I were to graph the midline, this would be our midline. You can see it goes right through the middle of the function, and that's why the amplitude's 2. That's that from the midline up to that point would be 2, and from the midline down to that point would be 2 units as well. Okay, the domain of this function, or the x values, we can see that x is just going to go from -infinity to infinity. The range, or the y values, we see that this function just oscillates back and forth around that midline. So we know that the y values are never going to go lower, in this case, than -5. Okay? But they will also never be greater than -1. Okay? Now here, I'm going to make this adjustment. A lot of people will want to put those parentheses in. Make sure you're not writing the parentheses there, because we're actually going to include these points, -5 and -1. You can see that there's actual points on these -5 y outputs, and there's actual points on these -1 outputs. So because we're including those points, we want to make sure that we put brackets. Remember, brackets are inclusive. Okay. All right, and that's all that I have for you.